Hello guys and welcome back. So first of all I will say that don't judge my painting right here. Okay, this painting is just for your understanding. So in this video what we will do, we will detect the climb points. As you saw in the introductory video, if there is any climb point on which the player will jump, okay, we need to detect that climb point. So for detecting the climb point, what we will do is, for example, if this is our wall, okay, this circle, and on this circle we have this climb points, okay, you can imagine this as some bricks or some area to hold on in our environment, okay. And in order to detect this climb points, what we will do, from the player neck area we will create raycast in the upward direction like this, okay. And if that ray, or you can say any of that ray, touches a climb point, then we will detect that climb point, and then according to the height, or you can say the distance to that climb point, we will perform a jump up parkour action, or you can say a climb up parkour action, okay. So this was just a visualization. Now let's go ahead and do this inside our game. So first of all, let's say we will start climbing from this point, okay, or you can select any area inside the game where you want to perform the climbing. So what I will do here is, first of all, I will select this gate entry, okay. And what we're gonna do actually is, let's just remove that, and let's create a empty game object right here, okay. And let's name this as climb points, okay. And then inside this climb points we will create a climb point. So if we click on this 3D game object and then click on this cube, okay, this is the cube. What we will do with this is, we will change the scale XY to zero point 0.1, zero point 0.1, or actually let's do zero point 0.2, okay. And once you do that, let's move this. Actually, let me control Z and let's select the whole climb point, okay, and let's move it right here, okay. Let's move it a little bit down below so that it matches this area, okay. Let's move it inside, okay, and let's move it a little bit up here, okay, like this, and then make sure it matches this area fully, okay, like this. And when it matches this area, what we're gonna do now is select our cube, and let's name this as point 1, and then we will disable the mesh renderer, okay. Or for now we can actually enable it so that you guys can see what is happening with this point 1, okay. Then what we will do is, we will create a different layer for this, okay, just as we did for our obstacle. So let's create a layer by the name of climb, okay. You can name this whatever you want, but we will keep it simple. So select climb on this point 1, and right here, actually guys, let's change the scale of this to 1.2, okay. We want it a little bit wider like this, okay. And let's move it a little bit to this side so that the player don't touch with this thing, okay. I think right here it will be perfect. So once you created this climb point, now let's go ahead to the scripts folder, and right here we will create a new folder. Let's name this as climbing system, okay. And inside this climbing system we will create a new C# script by the name of climbing controller, okay. Let's open this up, and before working in this climbing controller, what we will do, as I told you, we will first of all detect the climb point. Okay, and in order to detect things, for that we have a separate script, which is the environment checker. Right here we check for ledges, and we also check for obstacles. So now what we're gonna do right here, we will also now check for climb points. Okay, so after this check ledge, we will create a new method for checking for the climbing points. But first of all, we need some variables. So what we're gonna do right here, we will create a header, and let's name this as climbing check. And inside this climbing check, what we will do, we will create a serialized field. Whoops. Okay, serialized field. This will be a float, and let's name this as climbing ray length. Okay, let's make the L capital right here, and this will be by default equals to 1.6. Okay, then after this we will create another serialize field. This will be of type layer mask. I don't know why it is printing this private with it. Okay, with our serialized field. Okay, so it will be of type layer mask, and let's name this as climbing layer. Okay, just as we did for our obstacle layer, we will name this in similar manner. Now after this, let's go ahead and create a method for this. After this check ledge, okay, let's say public bool, and let's name this as climbing check, or let's just say check climbing. Okay, because if we see our other methods, as you can see, we say check ledge and check obstacles, so we will name this as check climbing. Okay, and this will require two parameters. The first will be of type vector3, and this will be the direction. Okay, because we will be needing the direction in order to create a raycast in that direction, okay, in which the player is looking. And the next one is the raycast. So we will say out raycast hit and climb info. Okay, now in here what we will do, we will say ledge ray length, actually not that, we will say climb info, and this will be equals to new raycast hit. Okay, then after this we will say that if the direction, or you can say the dir, let's actually name this as direction. So we will click on change all occurrence. Okay, it will change both of that in the at the same time, but let's select the first dir if you don't have that option, and let's change its name to climb direction. Okay, and copy that, paste it right here. Okay, so if the climb direction is equals to vector3 dot 0, then what we will do, we will simply say return false. Then after this, now let's go ahead and create a climb origin. So we will say variable climb origin. This will be equals to transform dot position. Okay, and as I told you in the starting of this video that we will be creating a ray from the player neck, but now as you know that we use this transform dot position, and if we check our player, I think the ray will be now created from this middle point. Okay, because right here is the player main body connection part. Okay, So transform dot position, now as I told you, we will be creating rays in the upward direction, so we will say vector 3 dot up, and let's multiply that by 1.5 f. Then after this we will create an offset for this, so you will say climb offset. This will be equals to new vector 3. Okay, for the x let's pass 0, for the y let's pass 0.19, and for the z we will pass 0 as well. That is it. When we have the offset, now let's create arrays. Okay, we will not be creating one ray as I told you, because in our game the climb point will be a little bit higher from the player height, so that's why we will be creating multiple rays. Okay, so for that purpose we will create a for loop. But first of all, let's go ahead at the top and right here let's create a public integer by the name of number of rays, and number of rays by default will be 12. Okay, we will be creating 12 rays in the upward direction. Let's copy this name. Now let's get down to the for loop, and what we're gonna do, we will create an integer by the name I, and this will be equals to 0. Then we will say that if this I is less than the number of rays, it means that if not all of the 12 rays are created, then what we're going to do, we will create, so we will say I plus plus. I hope you know this simple programming. Then in here, now let's actually create the rays. So in order to create it, we will say physics dot raycast. Let's pass the climb origin, so we will first of all pass the climb origin. Then after this we will pass the offset, so let's pass the climb offset. Then we will multiply this by I. Okay, and then we will pass the climb direction, and after this we will store the information of whatever this ray hits, so we will say out raycast hit. Okay, and then we will name this as hit. Then we will pass the ray length of the climb. Okay, so climbing ray length is its name, so we will pass that right here. Then at the end we will pass the layer, so we will say climbing layer. Okay, and what we're gonna say in the start, if we are detecting any climbing point, then what we will do, we will store whatever this ray hit inside our climbing info, so we will say climb info equals to hit. Okay, then we will say return true. That is it. And if we don't detect anything, then at the outside this for loop we will simply say return false. Okay, now after this let's get back to our climbing controller script, and now let's call that method right here. So what we're gonna do, we will create a reference to our environment checker script, so we will say public environment checker, and this will be equals to environment checker. Okay, and after this, so what we will do, we will create a update method. Okay, if you want you can remove that summary, and if you don't have that summary then just leave it as it is. Okay, in here we will say that if input dot get button down, or let's just say get button, because we don't want to press the button again and again, or let's just actually change it to get button down, since we will be pressing it when we are performing the climbing actions. Okay, so if the jump button is pressed, or you can say the space button, and guys, if you are confused where this button is coming from, then if I show you the edit project settings, then input manager, right here we have this jump button automatically set inside Unity, which is the space button. Okay, so if the space button is pressed, then we want to check for the climb points. So we will say if the environment checker dot climb check, actually it is check climb. Okay, so if you see it right here, it is check climbing. So copy that, paste it right here, and as you know that it needs two parameters. The first one is the climb direction and then the raycast. Okay, so for the direction we will simply say transform dot forward, and then for the ray we will say out raycast hit. Let's pass the climb info. Okay, and then in here when we found any climb point, we will say climb point found. Okay, and now if you get back to the environment checker, we need to show these number of rays. Okay, so in order to show these rays, what we will do right here, we will say debug dot draw ray. Okay, we will pass the climb origin, and then we will say plus climb offset, and then we will multiply that by I, and then we will pass the climb direction. So climb direction, that is it. And after this, if we notice this line 79, let's add a semicolon right there because we forgot to add it. Okay, we have these three variables right there, and I noticed this thing that we created this as an integer, this number of rays, but at the end we type f. Okay, make sure that you remove f because this is an integer. Okay, and once you do that, save the script, get back to Unity, and then if we click on the player, let's see the environment checker script. Okay, right here we need to provide the climbing layer, so let's pass the climbing layer. We have the number of rays set up, and I think that is it. Okay, we are ready to test this out, but let's just test it out. I think it will show an error because we didn't pass the environment checker script to our climbing controller script. Okay, for example, if we try to, oops, I think the surface layer is not attached there. Okay, but let's just first of all test it out. If we press the space button, okay, right here, as you can see, the rays are not creating since the environment checker script is not attached to our climbing controller script. Okay, this I'm talking about this thing. Okay, so what we will do actually right here is that we will remove this public from there. Then after this we will create a awake method, and in this we will say environment checker equals to get component, and we want to get the environment checker script, so we will say environment checker, and that is it. Okay, now let's go ahead and select this area, and to this let's add the surface layer. Okay, yes, change children. Okay, and also make sure that to the point 1 you added the climb layer, okay, and that climb layer is selected right here in the climbing layer. And after this, let's drag and drop our climbing script right here after this parkour controller script. And when you do that, let's now go ahead and play the game. And when we play the game, and now if we try to press the jump button, okay, as you can see, you can notice these rays right there, okay. We can't see the rays because we are pressing the jump button again and again. So in order to fix this, let's now actually use just get button, okay. Remove the down keyword from there, okay. And now if we play it again, let's now press the jump button. Now you can notice there are the 12 frames coming from the player point, as you can see, from the player up a little bit down below from the neck, okay, because we set the offset, okay, for the raise, and the offset is right there in the neck, I mean a little bit down below from the player neck position, okay. That is the reason why we created a offset for our climb ray cast. So now if we go ahead on top of this, and now right here if we press the jump button, as you can see it is not detecting it since the rays are a little bit inside the house. So if we move down a little bit and let's get right here, as you can see now it is showing that climb point found, okay. As you can see right here, climb point found. If we press the jump button again, as you can see it is showing climb point found, okay. So in this way you can detect the climb points, okay. Now the last thing which we want to do is to give another color to our rays because we can't see the white color, okay. So right here at the end we will say color dot red, okay. I have copy and paste that from here, color dot blue, so you can just paste that right here and change it to red, okay. And once you do that, let's click on the player right here. Let's increase the width of this player a little bit because it is too small, so we will change this to 4. Actually let's change it to 3, and I think that will be it. So now if we play it again, now let's try press the space button. As you can see the rays are creating, and if you try to increase the number of rays to, for example, 20, as you can see now there are even more rays. So you can set this number of raise values according to your own need. And now with our climb point deduction ready, let's end this video right here.